Hello, this is Sarbir. This is our second video on the topic modeling with first order differential equation. This video is also a collaboration with my student Greg. I will set up the problem and he will finish this problem. So here we have a word problem. So this problem is also a mixing solution problem. The first we will read the problem and if it is possible, we will draw a diagram. So let's read a problem. So in this problems, we have a pond. So I'm going to draw a pond, which is, you can draw it like a tub. And initially that has 10 million, means 10 to the power 6 gallons of water. Water containing an undesirable chemical flow into the pond at a rate. So the rate which the chemical is pouring is 5 million gallon per year. So every year there are 5 million gallons will pour into the pond. The solution which is pouring into the pond, it is concentration is given 2 plus sine 2t. So it is a varying concentration with time. So every year different concentration of the liquid has been poured into the pond. And also there is an outlet in the pond where the water is gonna go out, and it go out with a same rate, which is 5 million gallon per year. So it means the water which is stay in the pond, it will always will be constant. It will always will be 10 millions gallon, because the rate of the water which is flowing in and the rate of the water which is flowing out is same. So now first we will basically defines the variable which we need to find. So we will say that the chemical, let's say Q of T is the amount of chemical, the amount of chemical in the pond at any time t. So let if the time evolves and Q2 is the amount of chemical, which is this is what we assume. This is what we need to find, how much is chemicals in the pond at a given time t. So I assume Q of T is the amount of chemical in the given time. So now we know basically the formula which I discussed in the previous video. The rate of change of QT. QT is the chemical, how the chemical will change into the pound. This will be is equal to the rate of change QT enter minus rate at which rate of change at which QT exit. So rate is enter and rate at which the QT is exit. So now let's see what is the rate of change. This is a d over dt. QT is the chemical, that is the rate of change of the chemical in the pound. What is the rate of change of the QT enter? It is going to be a flow rate, which is a 5 million times the concentration. This time it is a 2 plus sine 2t. So this is the rate of change. The chemical is entering into the water, and there's going to be a negative sign and the rate at which is exiting. So the flow rate is same. but what is the concentration after some time um, in the pound? So the concentration is, because Qt is, we assume that Qt is the amount of chemical is going to be present in the pound after some time t, and how much is the water in the pound? It is basically 10 to the power 10, 10 times 10 to the power 6, means 10 million. Since the 5 million gallon enter and 5 million gallon basically exit, so that will be, if you plus 5 million and you subtract 5 million, so which will basically just be 10 millions left in the pound. So now we have basically the differential equation. So here, if I write it d over dt q of t, and this is equal to 5 million 2 plus sine 2t minus that cancel out 10 to the power 6, and therefore this is a 1 half q of t. And also there is a initial condition, and like what was the amount of, because this is an initial value problem, what was the amount of chemical in the time 0, which is 0, because it was the fresh water in the pound when they start pouring the chemical into the pound. So this is our differential equation. Now we have to use the method from our previous video to solve this differential equation. So next of the videos will be basically done by one of my student, Greg. He will solve this differential equation and will give you the particular solution to that problem.
Okay, so we're solving this differential equation. Oh, I forgot the 5 times 10 to the 6, or whatever, you know what it should be. And so I do the integrating factors, e to the t over 2. And then we use the linear first order stuff. So we have e to the negative 2 over 2, and we have the 10 to the 6 there, which is correct. Then we have net integral. And then we split the integral as normal. Okay. So and then we use the formula to find the integral of e to the t over 2 sine 2t. That's plugging stuff in. We square stuff in the denominator, multiply the numerator and denominator by 4, and then distribute to get that. And therefore, q of t is this mass. Just we did the integral of 2e to the 2t, which was 4e to the t, and a bunch of stuff. So we distribute the 5 times 10 to the 6 and to get a bunch of stuff 10 to the 7. And then we get q of t is this. 2 times 10 to the 7 plus 10 to the 7 over 17 sine of 2t plus minus 4 times 10 to the 7 over 17 cosine of 2t plus ce to the negative t over 2. We find c by plugging in 0 and setting that equal to 0, so we get this bit over here equals 0. So c is 4 times 10 to the 7 over 17 minus 2 times 10 to the 7, which is 3 times 10 to the 8 over 17. Negative. So that means our q of t is this function down at the bottom. Yay! And this is what the function looks like. The y-axis is metric tons, and the x-axis is years.